for set theory. This is not so much new ideas as kind of expounding on what we already have and getting into some notation that's really gross. Now, if I just have three sets, set A, B, and C, or set A, sub 1, A sub 2, A sub 3, it's not so bad. But what if I had infinitely many sets? What if I said, for example, I'm going to let A sub I equal the set of the interval from I to I plus 2. And I is an element of the natural numbers, or the integers. Let's do the natural numbers. If I want to talk about doing the union of all of these, I could say A1 union A2 union ... But the dot's going forever. And it's not closed. And mathematicians like things kind of closed. The dots are annoying. So I could also write this as a big U, meaning union, of A sub I, but then I need to tell you what the I is. I'm going to say I is an element of the natural numbers. And of course, if I take the union of all of these things, what is the union of all these things? That's an interesting question. Did I go off the page? Since I'm actually doing the interval from I to I plus 1, I'm getting all the real number goodies on the inside. So this, and it will go from 1 to infinity, all the real numbers. Since the natural numbers start at 1, we're not going to get that crap between 0 and 1. It has to start at 1. If I were to say the intersection, same idea, of A sub I, where I is a natural number, well, there's nothing that's in all of them because the intervals just kind of move along. So the intersection of all of them is empty. This is a notation I want to talk about today, or in this video. Another possibility, what if the set that you are indexing with, using, like instead of natural numbers, you actually have an uncountably many thing, or even better, let's say delta equals math classes at SLU. And you would say that X, if beta is an element of delta, that would be like beta equals bridge class. Oh, see what I did there? Now, I'm going to define A sub beta, or A sub beta, as being the students, the set containing the students in beta. So, let's see, what can I do with this? So, it's not so much of beta is equal to 1, 2, 3, 4, or 5. Beta is this nebulous, well, it could be bridge class, it could be linear algebra, it could be the other bridge class, it could be a whole bunch of things. But it's not, we don't label them with numbers, we label them with names. So, that's why we're going to use a different notation. If I want to take the union of all of these, of A sub beta, it's like, well, what's beta? Beta is some element of delta. It's supposed to be an element of, sorry, my pen is messing up. Or I want to take the intersection of A sub beta, where beta is in delta. That would be, is there a student who's in all the math classes? Well, no. I know that. If I took the union of everybody, I have no idea what I would get. Lots of students. But anyone who's taking a math class this semester. So this is just an alternate notation, and you shouldn't freak out about it. But, you know, notation can be a pain in the butt. So let's do something funky. And the best way to deal with notation is write down a couple of examples to see what's going on. So if I say something like, I'm looking at the homework problems. If I say we're going to let A sub n equal the set of n plus 1 up to 2n. Then I would say, let's see, if I want the union of everybody, n, let's say n is a natural number. What does this mean? Well, let's see what we got. We've got a sub 1 is the set containing 1, 2. A sub 2 is going to start with 2 and then go to 2 times 2, which is 4. A sub 3 equals 3, 4, 5, 6, etc. Now you can see that the start of these sets keeps moving, and they keep going farther and farther out to the left, to the right. Sorry, I don't know about my left and right. So the union of all of these, well, we've got 1, and eventually we will get all the natural numbers. So if I take the union of all these, I'm going to get the natural numbers. If I want the intersection of all of these, well, there's no number that's going to be in all of them. If you say, what about 50? Well, I'll say a sub 51 doesn't have 50 in it. So there's nothing that's in all of the sets. Now, just like we had those theorems before, where we said A is a subset of A union B. Basically, the idea is A is a subset of a union where A is one of the people in the union, thing in the union. I can similarly say that A sub beta is a subset of the union of A sub, oh, I need a different subscript, A sub alpha, where alpha is in delta if beta is in delta. Okay, that's saying that if beta is one of the deltas, and alpha sub beta is one of the elements in this family of sets, then it's going to be in the union of all of them. If I say A intersection B is a subset of the intersection of A and B, analogously over here, no, not the page, I can say, again, assuming alpha, beta is an element of delta, I will say that the intersection of A sub alphas, where alpha is in delta, is a subset of A sub beta. Now, why did I say alpha here and beta here? Well, because I want to make this guy has to be more generic, and this has to be some specific beta I pulled from delta. So this is mainly a notational thing that we're going to need to work with and practice with, but I have faith in you that you will have no problem handling it.